Hi everyone, hi learners. In this lesson, I just want us to revise a grade 11 2021 March question paper. As you can see, the paper is in front of me. You can also see. In this question paper, we have question 1, where 1.1 we are required to solve for x in each of the following. Then 1.2, we are required to solve for x and y simultaneously. Then we've got 1.3, where we need to discuss the nature of roots of the equation. The equation is given. Then we've got 1.4, where we need to determine the values of p if g at x is equal to negative 2x squared minus px plus 3 has a maximum value of 3 and 1 over 8. Now let us move on. Question 2, 2.1, we are required to simplify fully without using a calculator. 2.2, we need to solve for x. 2.2.1 up to 2.2.3, as you can see. 2.3, without using a calculator, we need to show that square root of 2 all over square root of 2 plus 1 plus 4 over square root of 2 simplifies to 2 plus square root 2. Right. Then question 3 now. In question 3, 3.1, if 3 sine theta is equal to 2 and cos theta is less than 0, with the aid of a sketch or diagram, calculate the value of the following. 3.1.1, 3 tan squared theta times 5 cos theta, and also it is stated that you need to leave your answer in a set form. 3.1.2, cos into 180 degrees minus theta. Leave your answer in set form again. Then 3.1.3, we need to find the value of theta. 3.2, if tan 20 degrees is equal to m, determine the following in terms of m without the use of a calculator. 3.2.1, sine 70 degrees. 3.2.2, tan squared 250 degrees plus sine squared 560 degrees. 3.2, 3.3, simplify without using a calculator. We've got 3.3.1, then we've got 3.3.2. Then 3.4, we are required to prove that sine x, that's 2 sine x cos x minus tan x all over cos squared x minus sine x, sine squared x is equal to tan x. As you can see, it is written error, which means there is an error in this proving, or in 3.4 there is an error. Then we've got 3.5, where we need to determine the general solution for 2 sine squared x minus sine x, which is equal to 0. Then 3.5 is our last problem to do in this question paper. Right, I think now we need to start. Okay, let us start. As you can see here, I've got my I've got my question 1 with 1.1 where we need to solve for x. Right, now let us start. In order to solve for x here, you need to equate this 2x to 0 and also whatever is inside brackets to 0 again, meaning we will have 2x is equal to 0 or x minus 3 is equal to 0. Okay, now if we divide both sides by 2 here, we will get x equals to 0 or x is equal to positive 3 because we will transpose this negative 3 to the right hand side. Right, we are done with 1.1. Now, viewers and learners, let us move to 1.1.2 where again we are required to solve for x. And it is stated that we need to correct to 2 decimal places. Once you see that correct to 2 decimal places inside brackets, it tells you that you need to use a quadratic formula. Okay, firstly, we need to write this equation as a quadratic equation. Right, we have 3x squared minus 2x, and we need to transpose this positive 4, and it will be negative 4 equals to 0. Now we know that a is equals to 3, b is equals to negative 2, and c is equals to negative 4. Right, now we need to write the quadratic formula, which is x is equals to negative b plus or minus square roots b squared minus 4ac all over 2a. The only thing now we need to do is to substitute. X is equals to negative, then b is negative 2, meaning we'll have negative 2 plus or minus square roots of negative 2 squared minus 4. A is 3, C is negative 4. The square root should cover everything all over. I mean the division sign, not the square root. The division sign should cover everything all over. 2 times A is 3. Then we need to put all this information in a calculator. Right, if we put this information of the calculator, we find that x is equals to 1, 5, 4, or x is equals to negative 0, 8, 7. Right, we're done with 1.1.2. Now let us move on to 1.1.3. Here, we need to equate this bracket to 0 and also this bracket to 0, meaning we will have x minus 1 greater or equals to 0 or 4 minus x greater or equals to 0. Now we need to transpose x greater or equals to 1 or negative x greater or equals to negative 4. Okay, in this case, we need to divide both sides by negative 1 by negative 1. Then once we divide by a negative number, the inequality sign changes. Since it was greater than or equals to, now we will have x less than or equals to positive 4 as our final answer in this problem. Right. Let us move on now to 1.1.4, where also we need to solve for x. Here, the first thing we need to do is to eliminate this square root. How do we do that? We need to apply squared on both sides. Right, on the left hand side, we will have 5 minus x, which is equals to x plus 1, x plus 1, since we have squared there. Now we will have 5 minus x, which is equals to x squared, x and 1 plus x, 1 times x, which is also x plus 1. Now we have 5 minus x, which is equals to x squared plus 2x plus 1. Now we need to transpose. Okay. Now we will have x squared plus 2x plus x plus 1 minus 5. That is equals to what? 0. X squared, this is going to be 3x minus 4, which is equal to what? 0. Now we are required to factorize this quadratic equation. We will open the brackets, equals to 0. Then we need the factors of 4 that will give us the middle term, which is 3. Those factors are x plus 4 and x minus 1. Remember, the bigger number always takes the sign of the middle term. Since the middle term is positive, then the bigger number in brackets, which is 4, will be positive. Now, x is equals to negative 4, or x is equals to positive 1. Okay. Right. Now, how do we check if both of these are the solution of this problem or not? If we put this negative form in that equation, the left hand side is not equals to the right hand side. You can also do that. Therefore, we can say x is equals to negative 4 is not a solution. Therefore, x is equals to 1. Right. Now let us move to 1.2, where we are required to solve the simultaneous equation. Right. Firstly, you can see here, you can say this is equation 1. Then we can say this is equation 2. Then from equation 1, we can form equation 3, which is gonna be x is equals to 2y minus 4. This is equation 3. Right. Let us move on. Now we need to substitute equation 3 in equation 2, meaning we will have, where there is x, we will put 2y minus 4. Okay, let us do that. We have y squared minus, where there is x, we need to put 2y minus 4. Then we have y plus what? Plus 21. That is equals to what? That is equals to 0. Right. Now we will have y squared minus y times 2y. That is gonna be negative 2y squared. Then y times, okay, negative in negative is gonna be positive. Then y times 4 is gonna be 4y. Right. Gonna be 4y, okay, plus what? Plus 21, which is equals to what? 0. Now we will have y squared. Oh, sorry. Now we've got like terms. Now we need to add and subtract like terms. Y squared minus 2y squared, that is going to be negative y squared, plus 4y plus 21, that is equals to what? That is equals to 0. Right. Now we need to divide throughout by negative, meaning we will have y squared minus 4y minus 21, that is equals to what? 0. Right. Now we need the factors of 21 that will give us the unity term, which is 4. Now we need to factorize. We will have y minus 7 and y plus 3. Right. Therefore, y is equals to 7 or y is equals to negative 3. Right. Now, in order to get the values of x, we need to substitute y is equal to 7 and y is equals to negative 3 in equation 3. Right, let us go back to equation 3. Let's go back to equation 3. Equation 3 is x is equals to 2y minus 4. X is equals to 2y minus 4. Right. X is equals to y minus 4. Now let us substitute. We will have x is equals to 2. Where there is y, we put 7 minus what? Minus 4, which is equals to what? 2 times 7, that is what? That is 14. 14 minus 4, that is 10. Meaning x is equal to 10. And also, we need to substitute negative 3. Meaning we have x is equal to 2. Where there is y, we put negative 3 minus what? Minus 4. Therefore, 2 times negative 3, that is negative 6. Negative 6 minus 4, that is negative. That is negative what? That is negative 10. Right. Moving on to 1.3. Discuss the nature of roots of 2 into x minus 3 all squared plus 2. Right, what we need to do here first, we need to split this, meaning we will have 2 into x minus 3, x minus 3 plus 2. Then now we will have 2 x times x, that is x squared, x times negative 3, that is negative 3x, negative 3 times x, that is negative 3x plus 9 plus 2. That is equals to what? Equals to 0. There is 0 here also. There is 0 there also. Right, now we have 2 into x squared minus 6x plus 9. Where do we get this? Negative 6x, that is negative 3x minus 3x. Right, plus what? Plus 2 equals to 0. Now let us remove the brackets. We will have 2 times x squared, which is 2x squared, 2 times negative 6x, that is negative 12x, 2 times 9, that is positive 18 plus 2 equals to what? 0. Right, now we have 2x squared minus 12x plus 20 equals to 0. Now we know that in order to discuss the nature of roots, we need to use the discriminant. The discriminant is equals to b squared minus 4ac. If the discriminant is less than 0, therefore the roots are non-real. If the discriminant is greater than 0, the roots are real. If the discriminant is equals to 0, the roots are real and equal. Right now, in this equation, our A is equals to 2, B is equals to negative 12, C equals to 20. Right now, let us substitute. Discriminant is equals to B squared, where there is B, we put negative 12 squared, right, negative 12 squared minus 4, where there is A, we put 2, where there is C, we put 20. If we put this information in our calculator, we will find that, okay, let us put this information in the calculator. Now, the discriminant is equals to negative 4. Therefore, we can say the discriminant is less than 0. Then we can conclude that the roots of this equation are non-real. Why they are non-real? Because the discriminant is less than 0, meaning discriminant is negative. Right. Now let us move on to 1.4. 1.4, determine the values of P if g at x is equal to negative 2x squared minus px plus 3 has a maximum value of 3 and 1 over 8. What we need to do here is that we need to substitute 3 and 1 over 8 where there is x, meaning we have g at 3 and 1 over 8, which is equals to negative 2 into 3 and 1 over 8 squared minus p into 3 and 1 over 8 plus 3. Right now, let us use our calculators in order to make our life easy. Right, negative 2 into 3 and 1 over 8 all to the power 2. That will give us negative 625 all over 32 minus, this is 8 times 3, that is 24, plus 1, that is 25, meaning we have 25 over 8p plus what? Plus 3. Now the answer here should be negative 625 over 32 plus 3. Since they are like terms, it's gonna be 529 all over 32 minus 25 over 8p. That is our final answer. Right. Question 2 now. We are moving. I hope it's still clear to everyone who is watching. Question 2. We shall simplify without using a calculator into point 1. Right. We have 3 to the power 2x plus 1 times 15 to the power 2x minus 3 all over 27 to the power x minus 1 times 3 to the power x times 5 to the power 2x minus 4. Right. Okay, let us move. Here we can pay this one. We will write it as it is, meaning we will have 3 to the power 2x plus 1 times, then this 15 we can split it into 3 to the power 2x minus 3 times 5 to the power 2x minus 3 all over this 27 can be written as 3 to the power 3x minus 3 times 3 to the power x times 5 to the power 2x minus 4. Right. Moving on. Now we will have, right, we've got prime bases. Now we can keep the prime base, and we can keep one prime base. Okay, now we will have 3 to the power 2x plus 1. Now we need to apply the laws of exponents. Okay, plus, since we are adding powers of this, we are multiplying powers of the same base, we add the exponents. Plus what? Plus 2x minus 3. Okay, now we are dividing, since the 3 to the power 3x minus 3 is in the denominator. Now we need to subtract this 3x minus 3 and put the brackets 3x minus 3. Right, minus what? Minus this x times what? Times 5 to the power 2x minus 3, then subtract this 2x minus 4 minus 2x minus 4. Right, this 2x and this 2x will give us 4x. Okay, let's remove the bracket first. We will have 3 to the power, this 2x and this 2x gonna be 4x, 1 and 1 minus 1 minus 3, there is minus 2, a minus 3x plus 3 is negative, then minus x is x times what? Times 5 to the power 2x minus 3x minus 2x plus 4. Right. 4x minus 3x, that is 1x. 1x minus 1x, meaning all these cancel each other and make n equals to 0. Right, negative 2 plus 3, that is 1, meaning we will have 3 here. Then 2x minus 3x, that is negative x. Two x minus 3x, that is negative, that is negative, that is negative x, negative x minus x. Oh, sorry, I did a mistake here. There is no x here because we've got only 3. Okay, now let me erase this. Let me erase this x. There is no x here. We've got 3 only. Right. Now, 2x and 2x cancel each other. Then we've got negative 3 plus 4, which is 1, meaning we have 5 only here. Then we will have 3 times 5, which is equals to 15, meaning 15 is going to be our final answer. Alright, moving on to the next question, which is 2.2, where we need to solve for x. How do we solve for x here? Firstly, we need to do something in brackets. What is it we need to do? We need to write this 1 over 2 with a negative exponent, which means we will have 2 to the power negative, no, we'll have 2 to the power negative 1. I don't know what I'm writing here. Okay, we will have 2 to the power negative 1 all to the power x, which is equal to what? We can change this 32 and write it exponentially as 2 to the power 5. Right. Now, we need to remove brackets and have 2 to the power negative 1 times x, that is negative x, which is equal to what? 2 to the power 5. Now, we know in laws of exponents that when bases are the same, what we need to do is that we need to equate the exponents. The exponents here are negative x is equals to 5, and divide both sides by negative 1. Therefore, x is equals to 5. Right. Now let's move on. We've got 2.2.2, where we have cube root of 1 over x squared is equals to 4. We can also write this 1 over x squared as cube roots of x to the power negative 2, which is equals to 4. Right. Okay, moving on, we can remove the square root now, the cube root now. We will have x to the power negative 2. Cube root is 1 over 3, which is equals to what? Which is equals to 4. This is not allowed. Mathematics. Right. Now, we will have x to the power negative 2 over 3. Come on, let me write this nicely. Just like this. Should be clean. Alright, now we will have x to the power negative 2 over 3 equals to, we can change this 4 and write it as 2 to the power 2. Right. Now we will have x to the power negative 2 over 3. In order to eliminate this negative 2 over 3, we need to multiply by its reciprocal, which is negative 3 over 2. But we need to do that on both sides. Then here we will multiply the exponent by negative 3 over 2. Right, this negative 2 will divide this negative 2, 3 and 3. Then on the right, on the left hand side, we have x equals to these 2 and these 2 will divide each other, meaning we have 2 to the power negative 3. We can write this 2 to the power negative 3 x with a positive exponent as x is equals to 1 over positive 8. Right. Let's move on now. 2.2.3, where we have 2 to the power x minus 12 over 2 to the power x is equals to negative 4. Right. The first thing we need to do is to multiply throughout by this 2 to the power x, meaning we will have 2 to the power x times 2 to the power x minus 12 over 2 to the power x times 2 to the power x, which is equal to negative 4 times 2 to the power x. Right. Okay. Now we will have, since we are multiplying powers of the same base, we keep the base and add the exponents. X plus x, that is 2x, minus this 2 to the power x and this 2 to the power x divide each other. Here we have 12 equals to negative 4 to the power of x. Now let us transpose this. If we transpose this, we will have 2 to the power 2x plus 4 times 2 to the power x minus 12. That is equals to 0. Now, the only method that is going to help us here is to use the k method, where we need to let k equals to 2 to the power of x. Then where there is 2 to the power x, we put k. Meaning here we will have k squared plus 4k minus 12, which is equals to 0. Why we put, okay, let me split this. Here we have 2 to the power 2x. This can be written as 2 to the power x, then we put 2 outside brackets. That is why we say k squared, because where there is 2 to the power x, we put k, then we have k squared. Right now, we need to factorize this. If we factorize this, we will have k plus 6 and I made a mistake here, sorry. K, I will have k minus 2, those are the factors of 12, which will give us the middle term, which is 4. Right. Now, k is equal to -6, or k is equal to 2. Now, this one, k is equal to -6 is not applicable. Then now we'll use k is equal to 2. Right. Okay, we know that k is what? K is 2 to the power x, which is equal to what? Which is equal to 2 to the power of 1. Therefore, x is equal to 1 is our final answer in this equation. Now, let us move on to 2.3. Without using a calculator, show that the following simplifies to 2 plus square root 2. Right. Let us start. Okay. Now, let us write this as it is. Square root of 2 all over square root of 2 plus 1 plus 4 over square root 2. Right. This is equals to, right, here we can use two methods. We can find the LCD of this. The LCD here is, square root 2 plus 1 and square root 2. Right, this divided by this is 1. Square root of 2 times square root of 2, there is 2. Right, plus the plus 4 into square root 2 plus 1, because the square root 2 will divide the square root 2 and eliminate the square root of 2. Now we need to simplify this. 2 plus 4 times square root 2 is 4 square root 2. 4 times 1, there is 4 all over. Let us simplify this. Square root of 2 times square root of 2, there is 2. Square root of 2 times 1, there is plus square root of 2. Right, moving on. We need to move on now. 2 plus 2 plus 4, there is what? There is 6 plus square root of plus 4 square root of 2 all over 2 plus square root of 2. Now we need to rationalize the denominator. If we rationalize the denominator here, we will have times 2 minus square root of 2 all over 2 minus square root of 2. That is how we rationalize the denominator. Now let us work this out. we will have the brackets will help us here. The bracket will help us. 6 times 2, there is 12. 6 times negative square root of 2 is going to be negative 6 square root 2. Positive 4 square root 2 times 2, there is positive 8 square root of 2. Then 4 square root 2 times negative square root 2, that is square root of 2 times square root of 2, that is 2. 4 times 2, that is negative 8 all over 2 times 2, that is 4. 2 times negative square root 2, that is negative 2 square root 2. Positive square root 2 times positive 2, that is positive 2 square root of 2. Right, square root of 2 times negative square root 2, that is negative 2. Now let's work this out. Okay, 12 minus 8, there is 4. Right. Negative 6 square root 2 plus 8 square root 2, that is positive 2 square root 2 all over 4 minus 2, that is 2. This cancel each other and 0. Then in the numerator, we can take out the highest common factor, which is 2. Then we will have 2 plus square root 2 all over 2. This 2 and this 2 will divide each other. Therefore, the answer is 2 plus square root 2. Now it is shown that the answer is 2 plus square root of 2. Now let us move on to question 3. Question 3. If, okay, 3.1, if 3 sine theta is equal to 2 and cos theta is less than 0, with the aid of a sketch, calculate the value of the following. Right. Since it is stated that we need to use a sketch in order to calculate the following, therefore we need to draw the sketch first. And also, this cos theta is less than 0 is a restriction or is a quadrant. Right. Let us simplify this first. We will have sine theta. If we divide both sides by 3, we will have sine theta equals to 2 over 3. Now we need to look for a quadrant where sine is positive while cos is negative. That is the second quadrant. In this case, that is the second quadrant. Now let us draw the diagram. Okay, we will have a diagram like this. Right. And we will have this angle theta here, where we have here we have 2, then we have 3 here. We need to find x. We need to use the theorem of Pythagoras in order to calculate the value of x. X squared plus y squared is equal to r squared. x squared plus where there is y, we put 2 squared, which is equals to 3 squared. Now we will have x squared equals to 9 minus 4, because we transpose this 4. 9 minus 4 is what? Is 5. Now we need to apply the square root on both sides. Remember, the square root is plus or minus. Then we will check the quadrant and select the one we need. X is equal to negative square root of 5. Why we choose negative 5? Because in this quadrant or in this line, the value of x or the values of x are negative in this x-axis. Right here we have negative square root of 5. Right, now let us answer the question that is being asked. Okay, 3 times square theta times 5 cos theta. Okay, now we need to substitute and we need to give our answers or our answer in a set form. 3 tan is opposite over adjacent, meaning we will have 2 over, okay, we'll have negative here, square root of 5 all squared times 5 into cos is negative square root of 5 over 2. Cos is, no, over 3, not over 2. Cos is negative square root of 5 over 3. All, do we have squared? No, we don't have squared. Okay, that's all. Right. Without the waste of time, we can put this information in a calculator, and the answer is negative 4 square root of 5 is our answer. Right. 3.1.2 cos 180 degrees minus theta is cos theta. How is the sign? 180 degrees minus theta is in the second quadrant, and in that quadrant cos is what? Cos is negative. That is equal to, let us go back and check. Cos is negative root 5 over 3. Then here we have negative into negative square root of 5 over 3. Therefore, the final answer is square root of 5 over 3. Since this negative and negative multiply each other and give us positive. Alright. Now the value of theta. How are we going to find the value of theta? We can use the information that we already have in order to find the value of theta. We can use cos. Let us use cos. We can say arc cos of negative root 5 over 3. That is equal to 1. If we put this information in a calculator, we will get 1 38.19 degrees. Right. And the angle is correct because it is greater than 90 degrees. Right, let us move on to the next question. Three point two. If tan 20 degrees is equals to m, determine in terms of m without the use of a calculator. Let me clarify this thing of without using a calculator. If they say without using a calculator, it means you mustn't get a number. You mustn't get a decimal number. I want to emphasize that. If it is stated that without using a calculator, it's not that you won't use the calculator at all. It's just that we don't need a decimal number in your answer or in your answers. I want to emphasize that. Right. Now we have tan 20 degrees is equals to m. We know that this m has got a denominator of 1. Now we can draw a triangle, a right-angled triangle. Then we can put 20 degrees here. Then here we can put 70 degrees. Since we know that 20 plus 70 is equals to what? Is equals to 90 degrees, and the interior angles, the sum of interior angles of the triangle equals to 180 degrees. But we know that sine 20 degrees is equal to m over 1. 20 degrees, then we know that sine is opposite, meaning we put m here over adjacent. Here we have 1. Then we need to calculate r using the theorem of Pythagoras. X squared plus y squared is equal to r squared. Right. Now just substitute. Where there is x, we put 1 squared plus where there is y, we put m squared equals to what? R squared. We know this 1 squared is 1 plus what? Plus m squared equals to what? R squared. We want to remove the squared. We need to apply the square root on both sides. Therefore, r is equals to square root of 1 plus m squared. Right, now we are required to find the value of sine, to write sine 70 degrees in terms of m. Now we know that here we know that r here is 1 plus m squared. We've got 70 here, meaning sine 70 is going to be opposite, because 70 is here and 1 is opposite to 70. Meaning we have 1 over square root of 1 plus m squared as our answer. That is equals to 1 over square root of m squared plus 1. That's our final answer. Right. Number 2, we've got tan squared. We've got tan squared 250 degrees plus sine squared 560 degrees. We need to apply the elimination or reduction equations here, or reduction rules. Tan squared, we can reduce 250 or write 250 as 180 degrees plus 70 degrees plus what? Plus sine squared. We can write 560 as 360 degrees plus 200 degrees. That is equals to tan squared 70 degrees plus, in this quadrant, sine is positive, meaning we will have sine squared 200. Right. We can also reduce this sine 200. We can reduce this sine 200 tan squared 70 degrees plus sine squared into 180 degrees plus 20 degrees. Now, that is equals to tan squared 70 degrees. This is the third quadrant where sine is negative. Sine squared 20 degrees. Right. Therefore, we need now to write this in terms of m, meaning we know that tan is 1 over m. No. Tan is, yes, tan 70 degrees is 1 over m. Let us go back and check our diagram. Yes, tan 70 degrees is 1 over m. That is absolutely correct. Okay, now let us move on, viewers. I hope you are still with me. I can see it's such a long lesson. Okay, tan squared 70 degrees is 1 over m all to the power 2 minus sine squared 20 degrees is going to be m all over square roots of 1 plus m squared. Right. Gonna be all squared. Right. Then the final answer here is gonna be 1 over m squared minus m squared all over 1 plus m squared. This is our final answer in this question. 3.2. Without using a calculator, we need to simplify the following. Oh, it's 3.3 now. We are doing 3.3. Right. 3.3.1. Sine into 360 degrees minus x is in the fourth quadrant where sine is negative. Right. Times square root, we can change this to sine squared x all over I am so sorry, my line is not straight. Okay, all over what? This is 3 sine into 90 degrees minus x, which can be written as 3 cos x, since we know that once we have 90 degrees, we use the core ratios, times 180 degrees plus x is in the fourth quadrant, and in the fourth quadrant, not in the fourth quadrant, is in the third quadrant, and we know that in the third quadrant, cos is always negative. Right now we will have times, this computer now is slow. Okay, times what? Times negative cos x. Okay, let us put brackets. Right, equals to negative sine x times, this can be written as sine squared x times 1 over 2. These 2 and these 2 will divide each other. Right. All over what? All over 3 cos x times negative cos x. Right. Let's move on. Sometimes my computer is slow. Please bear with me. Right. This is gonna be equals to, okay, here, since we divide this 2 and this 2, now we will no longer have 2 as an exponent here. We will have negative sine x times positive sine x, which will be negative sine squared x all over negative 3 cos x times negative cos x is going to be 3, it's going to be negative 3 cos x. No, there is no squared here. Oh yes, there is squared. Now it's going to be negative 3 cos squared x. Right. Okay, now the final answer here, as I said, is 3 tan squared x. Since we know that sine over cos is tan. Right, now let us move on. 3.3.2, where we have tan 150 degrees times cos 10 degrees times sine 300 degrees all over sine 8 degrees times cos 225 degrees times sine 135. Right, we can write tan 150 as tan 180 degrees minus 8 degrees. We can write, then we have here cos 10 degrees. Sine 300 can be written as sine into 360 degrees minus 60 degrees all over sine 80 degrees can be written as sine into 90 degrees minus 10 degrees. Cos 225 can be written as cos 180 degrees. Why am I writing it back? 180 degrees plus 45 degrees. Then sine 135 can be written as sine 180 minus 45, 45 degrees. Right, now this is the second quadrant where tan is negative. We have tan 30 degrees times cos 10 degrees. This is the fourth quadrant where sine is negative, meaning we will have negative sine 60 degrees all over sine 90 degrees minus 10 is equals to cos 10 degrees times, this is the third quadrant where cos is negative, meaning we have cos 45 degrees times, this is the second quadrant where sine is negative. Now we have sine 45 degrees. That is equals to, we know the special angles, triangles. Okay, the first one is like this. We have a right angle, 30 degrees, 60 degrees. We have 1, we have 2, we have root 3. Then another one is the one for 45 degrees, which is like this. (45) and 45 here, and we've got 1, 1, and square root of 2. Right. Negative tan 30 degrees can be written as negative 1 over square root of 3. This cos 10 and this cos 10 divide each other, and negative sine 60 degrees can be written as negative square root of 3 over 2 all over negative cos 45 degrees can be written as negative 1 over square root 2. As you know, this cos 45 is, here is the triangle, cos 45 is 1 over square root of 2 times what? Times 1 over square root 2. That is equals to what? If you put all this information in a calculator as it is, the answer is negative 1. I know you are using casuals, therefore your life is so simple when it comes to mathematics. We know that 3.4 is having an errata, or is having an error. Then we can just move on to 3.5, where we are required to determine the general solution for 2 sine squared x minus sine x, which is equals to 0. Here we can take out the highest common factor, which is we have 2 sine squared x minus sine x is equal to 0. Right, we can take out the highest common factor, which is sine x. Then in brackets we have 2 sine x minus 1, which is equal to 0. Then this sine x is equal to 0, or 2 sine x minus 1 is equal to 0. Right, let me bring down this sine x, which is equal to 0, or sine x, this is x, which is equal to 1 over 2. Now, the values of x here, or the reference ends, are going to be x is equal to arc sine 0, or x is equal to arc sine 1 over 2. Therefore, here we will have x equals to 0, or x is equals to 30 degrees as our reference angles. Now, we haven't finished since we are solving for a general solution. Now we treat 0 as positive, meaning we need to look where sine is positive. Sine is positive in the first quadrant. Sine is positive in the first quadrant, meaning we will have, in the first quadrant, is going to be x is equals to 0 plus k times 360 degrees. Therefore, x is equals to k times 360 degrees, where k is the element of integers. Then we are still using 0. Okay, on the second quadrant, sine is still positive since we treat 0 degrees as positive, meaning we will have x is equals to 180 degrees minus 0 plus k times 360 degrees. Therefore, we have x is equals to 180 degrees plus k times 360 degrees, where k is the element of integers. Alright, now let us move to the reference angle, which is 30 degrees. Also, we know that sine is positive in the first quadrant and in the second quadrant. Right, first quadrant is gonna be x is equals to 30 degrees plus k times 360 degrees. K, where k is the element of integers. Right, then the second quadrant second quadrant, we will have x is equals to 180 degrees minus 30 degrees plus k times 360 degrees. Therefore, the answer is going to be x is equals to 150 degrees plus k times 360 degrees, where k is the element of integers. Okay, now the end. That is the end of our lesson. Please subscribe to Math Tutorial Sessions channel. Thank you so much for watching this video. Also, please make sure you hit the notification bell below this video in order to get a notification whenever we upload a new video. Thank you so much. Goodbye.